I will elaborate some more on the issues that Barry mentioned, and also reflect on some things that Marijke and Jan already mentioned in their presentation. So I'll try to mix some. I'll present you some key issues on monitoring and modeling we performed for our drought investigation in sandy areas of the Netherlands. I can't explain and can't tell you all because we did a lot of things. So I will use it as an illustration to try to make it clear to you how we did our research, how we investigated drought and its effects. But first, already, as the former speakers already announced and talked about, we had a huge flood in Germany, Belgium, and Netherlands this summer. So following 3 years of relative extreme drought, it was also a kind of extreme event with a lot of casualties, unfortunately. So this is also a big problem. But maybe as a next extreme event, the drought will follow. Who knows? The work I'm presenting was done by a lot of people from different institutes. Amongst them was Perry, some other colleagues. So I'll present part of the work we did. Some credits, of course, to them as well. I was the project leader of the investigation team, and we tried to finish the project within a month from now. We have a report available. It's unfortunately in Dutch. I think after the day maybe we should make a translation in English, but we'll have to see. So we started the project after a phone call from a colleague from the province of North Brabant. The program manager, I think, is here from the province. But Matthijs Markel called me as I was in the US in a desert area. He said, well, it's also warm and dry in Holland. Can you please elaborate and help us on doing some extra monitoring on nature areas by the airborne remote sensing? So that's how the project started. A relatively small question about monitoring nature areas and drought. Later on, we elaborated the project in a wider sense. As you can see from the maps from KNMI, left-hand side on the map from July 20, 2018, the potential rainfall deficit compared to right, the long-term average precipitation deficit on exactly that day. To give you an idea about what we did with the first question that was asked by the province of North Brabant, we hired an airplane and a pilot and a lot of cameras, and we took aerial pictures from, in this case, the Campina area with on the left-hand side, a false red color image. But we took several bands, visual bands, but also near-infrared, thermal infrared, and some microspectral imaging, to see whether we could estimate through calculating, for example, the relative ET on the right-hand side, to see drought effects on the ground in the specific nature areas. What you see on the right-hand side is a lot of blue colors, which is quite positive because the ET is relatively high. It was shortly after a rainfall event, after the drought, the extreme period of drought. So that was a picture made on August 17, after some rainfall events, local rainfall events from this nature area. So unfortunately for this area, we were too late to take images from the natural area on the most extremely drought period. Anyway, we had some other pictures as well, but I want to also show you that it's important, of course, in terms of monitoring, to time your monitoring very well, to know when and how to monitor your areas given the questions you have. Of course, the problems arise from dry weather and drought. Mike and Perry explained it to you. Several problems at several scales. In the end, of course, the landscape scale, but also the land use, the farming with crops, the nature area measures with the nature areas, but also the water infrastructure and the water system itself, of course. Severe problems, and probably given the present weather conditions and present climate change trends, there will be, of course, the future weather will change, it's already on the change, and change climate will induce probably more drought periods, so we need analysis. Of course, drier weather doesn't automatically mean that we are facing a drought period, because drought is a very abnormal situation. Of course, in Holland we also have streams that run dry every year, but that's could be quite normal, not really a drought issue, but as the streams are running dry that are normally not running dry, then you can speak of a drought. So a drought is a very severe abnormal situation. And of course the fluxes count. Fluxes starting of course with precipitation, but also evapotranspiration. Of course evapotranspiration will drop because of evapotranspiration reduction, because of drought. But also discharge by drainage is an important flux. Perry already mentioned, I think, in Holland we have a water infrastructure system that is basically laid out for drainage, to prevent the water stress instead of preventing drought stress. And also, of course, the groundwater recharge and seepage, also the water extraction are important fluxes to count, especially during dry periods. Fortunately, in Holland, we have some major rivers flowing in, like rivers Meuse and Rhine, and they will provide us with external water supply, so we're quite lucky to have those extra sources of water. The problem is though, and the question will be, is the water and water system in balance? And of course, as you all know, it was not during the drought period. So we have to move from dry weather to drought. And for that, we need data and information. Also, of course, models, but models also need, of course, data and information to get the models going. So we looked at the soil profile, groundwater heads, and surface water levels. We looked at the water for drinking water supply and water for agriculture, especially, of course, irrigation water from both surface water and groundwater. We also looked at nature areas and groundwater availability, looking at long-term monitoring networks to see whether we could find some relationships between drought and natural vegetation. And of course we looked at the external water supply, because they also provide fluxes of water to the Netherlands that are quite useful during dry periods. So the water was not in balance. So why would we monitor it? Especially during dry periods, but also before dry periods. Of course we want to know system status. How is our water system doing? How are the groundwater levels? How are the stream discharges? How are, for example, soil moisture conditions in the root zone? But also of course, we want to know whether there is a relationship between present drought and present, for example, number of natural species present in nature areas. So how do we monitor in Holland? Of course, as we also do as you also probably do in your countries, of course, manually, but also by visual observations by people that manage certain areas. And we use more frequently online censoring in Holland. And that's one of the issues I will show you later on, showing our drought portal, which will permanently use online censoring in the field to present daily actual data. So it leads to, of course, information and data on groundwater heads, stream discharges, etc., soil moisture conditions, but also agricultural production. We have a agricultural production registration system in Holland called the Bedrijf Informatie Network. So the agricultural crop production and prices are involved in that, but also in niche areas there are several monitoring programs running. But in the end, as we saw in Holland in 2018 especially, in the end the weather was dry, the water system was at a drought situation, but people took basically all the water they could, more or less. Drinking water companies took more, and the farm more than they were allowed to. So what do we need with that let's say observation? We need a future policy probably to look better into drought situations than we did before, with a more structural solution in terms of changing the water system. But also I think we need better enforcement of legal water issues, because if there is not enough water for everyone to supply everyone with, it's not of course the idea that everyone takes the water as much as he likes. We have to put limits, I think, to the water use in those periods. And of course, on a major, on a longer term, we probably need transitions from the water system point of view, from the water use point of view, and from maybe agricultural point of view. And I think by monitoring, we're starting to know how our system works. But also, of course, modeling is a very important part of the work and part of the analysis perform and we perform. Because we can interpret and integrate data in space and time, we can look whether we understand how the system works by running a model and see if we can represent data from the field. So we have, for example, 1D point models like the SWAP model, Jan already mentioned it. We have also the 2D transit models, but also the 3D area models like Perry mentioned, the National Hydrological Instrument, which are usually mechanistic, could be statistical, for example, time series models, and used in often cases we use dynamic models to model hydrology. So we want to see, of course, that our calculations match in a sufficient way our monitoring data, but maybe they don't do that well enough, either because the monitoring data are not well enough, either the model does not count all of the processes involved. So we have to look at that on those issues as well. But especially we faced, I think, in several cases, as well as hydrology, agriculture, and nature areas, we faced a lack of good monitoring data from the field. At present, during the drought, but also at a more or less long-term period before the drought occurred. So I think we have to think hard what to work on to improve both the modeling and monitoring. But I also experienced from this research that we better understand our system and better also understand our field data by modeling. To give an example of the analysis, we set up during the project a small monitoring network of soil moisture, especially soil moisture in the root zone. We typically installed sensors at two different depths, 15 and 30 centimeters below soil surface. And from the left-hand side graph, you can see in gray the data that we got through this online sensors from the beginning of the project, and in orange you can see the data. It's not really actual, but I think it's until day 240 from this year, so it's 1 week or 2 weeks old. So we present actual data on soil moisture, in this case from the Hubsel catchment at minus 15 centimeters below soil surface, and people can see how the root zone is doing in terms of soil water content, whether the plant faces a drought stress or not. We want to use it, of course, not only by looking at the soil moisture content in the root zone, but to combine it with meteorological information and groundwater information, of course. And then this is all work in progress. We are now trying to elaborate on, and I think already Jan told, you are already using the SWAP model, integrated into your monitoring portal. We are thinking about that too. Now, for this time, we only rely on field data. What we also did during the analysis is to combine modeling and remote sensing images. From satellite data, we calculated different vegetation indicators like NDVI, LAI, or NDMI. We plotted for several catchments time series of the calculated remote sensing vegetation indices, and we tried to compare those with, for example, calculated ET from the National Hydrological Instrument and calculated AT from other remote sensing sources. So we have three different sources, basically of let's say ET and transpiration information to look at catchment scale, development of drought, and of course you can see. Yeah, you can see from the third graph from the top, you see the big dip, 2018, September, August on NDMI. So it clearly shows that the moisture content of the vegetation covering the earth is dipping, showing that the vegetation is very dry in this particular catchment. And you can also see from the graphs that show, lower graphs that show you the calculated ET, but also the ET is dropping in August and September 2018. Very clear. So we try to combine different sources of information to look at, for example, in this case, ET for transpiration, of course. What we also did is to combine remote sensing images and calculations from that and modeling results on ET with registered crop production from in total I think 500 farms, dairy farms and arable farms in the Netherlands, for which the farmer registered this crop production on an annual basis. So there we try to combine agricultural information in the field by registrations of farmers with modeling results and remote sensing data. That's one part, because of course there was a lot of discussion in Holland also about crop damage during and after the drought. But also the pricing is important, and we all know that for several or most regions in Holland, if the weather in those regions runs dry and crops face drought stress, usually there's more drought stress in the EU, and the price per product will increase. So we found out through these registrations that although the crop production was dropping during the drought, if that lower crop production would be calculated, multiplied with the higher price, farmers would often be better off, or maybe be at a kind of break-even point. So from a financial point of view, there was also some positive news for agriculture. This is work in progress. People found out at Wageningen University that they have more data than they thought last December. So we are now elaborating with new data on especially irrigation and irrigation effects on crop production. See what these relationships that we earlier found are still valid or not, or can be, let's say, be more valid using irrigation information. So this will be work in progress. The next part I want to show you is to combine information on agricultural water use with remote sensing. In this case, we would use remote sensing to find out whether we can detect if a field, agricultural field, was irrigated or not. We developed an algorithm based on, I think it was 5 or 6 different bands from satellite images to give us an idea about parcels that were irrigated in 2018 or that were not irrigated in 2018. And the graph on the left-hand side shows you the map based on remote sensing data analysis, and in blue it would be an irrigated field, and the right part of the graph would be the same results for irrigated fields from the National Hydrological Instrument, and we saw, not always of course, but we saw a reasonable match between the two, so the model showed comparable results to the aerial distribution of irrigated plots if you compare that with remote sensing images on detection of irrigated fields. So also here we try to combine several sources of information to make the story more valid and to improve our, let's say, next step method. Shortly, I want to tell you something about nature. So we had a part of our research that was dealing with the effect of drought on the quality, let's say, of nature areas. And in the end, we had a lot of problems in proving that there was a lot of damage to the natural vegetation. We saw some, let's say, indicators. So there was some background, let's say, drawdown in natural areas quality because species disappeared. We had a rough time during the drought, but that was not always the case. And we found basically two things. We found that our monitoring data were basically not good enough and not frequent enough to draw really valid conclusions. Often the relation with hydrology in terms of monitoring data was not sufficient. So there were, for example, a lot of data on natural species in a natural area, but not a combination with a piezometer nearby or a 3-headed groundwater level. And in the end also we found that because, as Perry already explained, our drainage system in the Netherlands is basically designed for drainage. And given that situation, in combination with the relatively high groundwater extractions for agriculture and drinking water supply, nature already suffers quite a lot from structural drought induced by the layout of our water system and the water extractions. And the extra drought that we faced the last 3 years just do a little small addition to that damage that already has been caused during the last 20, 30 years in the Netherlands. But the major issue still is we need long-term monitoring on the quality of nature areas in combination with hydrology to make our conclusions more valid in maybe the next round of analysis. And that will mean that we have to hold on for years and years doing that type of work. And also what we need is to register rehabilitation measures in space and time, because nature area managers often have the best ideas with their areas. Sometimes they do not either completely or always register what they have done or what they are doing to rehabilitate the areas. So that's also information that you need when you try to analyze data. Okay, this map shows you different, or this slide shows you different maps and graphs to illustrate how we combine different sources of information and data. I can already explain most of them, but I want to also stress you're all probably researchers or maybe some postmasters. Keep using your common sense, because the model could be great, but you have to still check it whether it's logical or not. Then I think to conclude, I will show you 2 or 3 things about the drought portal that we have set up. I think one of the differences with the portal that Jan was talking about is that we use online actual data by telemetry. Overnight, we take all our data from our database and refresh the data with the data until yesterday, to give you an idea. It leads to this. No. Start with good cooperation, I think. So, to give you just a very short idea, and then I'll finish off. This is the map of the Netherlands, as you can see. The integrated precipitation data from KNMI, daily refreshed. Every sign shows you a meteorological station, and if you click on the data, the cumulative time series will appear, showing the cumulative precipitation for the present calendar year. So now you can see for station Wisp, at day number 250, it has about 500 millimeters of rain. And you can see from the gray lines in the back, those were the previous years. So then you have to interpret, well, okay, this could be quite average, but it doesn't say something about the P number or something. It's just a visual that you use. And from the precipitation, we calculate the standardized precipitation index. So instead of using the say the P values that were demonstrated before, we are using a standardized precipitation index for the last 3 months. So you're looking now at colors are not very clear, but you can see colors should range from, let's say, orange, which means dry, more dry than normal, to dark blue, more wet than normal, and the colors of the stations involved, which have enough data and have enough good data to be able to calculate the SPI, will be shown in a graph like this. So the color gives you an insight of how dry or how wet station observations are, and also we use the SPEI, so we also use the precipitation deficit, and that's what we only use this one for the main stations from KNMI. So the data are until I think September 4th updated, and it counts for the last 3 months. We also included, as I showed you before, for example, the soil moisture in the root zone. For example, for this station, it shows you this is for station Klarenbeek near the Veluwe forest area. Previous actual data in orange. On the left hand side, you see the volumetric percentage, like 30% at this stage. So it's quite wet. Last year and the year before it was quite dry. But I will stop here. What we also did is include also stream discharge. So on one hand, you can see the actual status of the water system outside by using data until yesterday, but we also can guide you through, from meteorology, through soil moisture, groundwater levels, and stream discharge. The information is all available in the portal. This is under development. Let's see. Okay, now I will. Acknowledgements. So, I'm not here only by myself, of course. I'm by myself. I did a lot of work with MFE, and also thanks to Mike and Terry who presented this work. We have some support by the interprovincial overleg. I don't know the EPO, and also from the water boards and homes that move on. That's a project and move on with their portal. We are happy with that, and it is, I think, I want to include in